Hello everyone, welcome back to my YouTube channel. Today I'll be explain what transitive closure is, how Warshall's algorithm works, its steps, why it uses dynamic programming, some real-life applications, and finally we'll see a coding example with output. So let's get started. What is transitive closure? First, let's understand what transitive closure means. The transitive closure of a directed graph shows which vertex or nodes can reach other nodes either directly or through other nodes. In simple words, if there is any path from node U to node V, then that pair is included in the transitive closure. This is useful because it helps answer reachability questions, like can I get from A to B somehow? So I have graph example in Warshall algorithms. So let's look at this simple graph. We have four vertices A, B, C, and D. There is an edge from A to B, B to D, D to C, and D to A. Transitive closure matrix. Here is the final transitive closure matrix. The rows and columns are labeled A, B, C, and D. A1 means there is a path between the nodes. A0 means there is no path. So A to A1, A to B1, A to C, A to C, 0. So A to C, 1, A to D, 1, B to A, 1, this row also 1, and third row 0, and the fourth row 1. Dynamic programming. To find this closure, we use dynamic programming. We built it step by step using matrices. The initial state matrix are 0. It is just the adjacency matrix. If there is a direct edge, we put a 1. If not, it says 0. So here are 0. A to A is 0. A to B is 0. 1. A to C is 0. A to D is 0. intermediary vertices. So in Warshall's algorithm, we check one vertex at a time as an intermediate vertex in R0. We have no intermediate vertices, so we use the initial adjacency matrix. So I calculate R1 and R2. We check path using vertex A as an intermediate point. If a path exits this directory or through A, we update the value to 1. So we check if any new connections appear when we allow a to be used in between. After checking, we get the update R1, R2 matrix. Then we move to R2. We choose vertex B as the intermediate vertex. We again update connections if any new path appear using B. We keep repeating this process for each vertex. So the binary matrix after all steps is our transitive closure, showing reachability between all pairs. So Warshall's algorithm is a simple, systematic way to compute transitive closure using dynamic programming. What is Warshall's algorithm? Now how do we compute the transitive closure? We use Warshall's algorithm, a classic and simple method. Warshall's algorithm uses dynamic programming to update reachability step by step. It starts with an adjacency metric of a graph. The output is a new matrix that shows which nodes can reach which other nodes. Why dynamic programming? So why do we use dynamic programming here? Because instead of testing all possible paths one by one, we build longer paths using shorter ones. This saves time. The algorithm uses the reachability we already know to find new reachability. This makes Warshall's algorithm simple and systematic. It runs in O time, which is efficient for graph or reasonable size. Where is Warshall's algorithm used? Let's see a few examples. First, in computer networks. to check if one computer can reach another through routers. Second, in compilers, to analyze which modules depend on which others. Third, in social network, to find friend of a friend connections. Fourth, in databases, to optimize queries by knowing connections. Basically, it is very useful when we need to find out if there is any way to get from one node to another. Now, let's look at a simple code example of Warshall's algorithm in C#. We take a small graph with 3 nodes. The adjacency matrix says node 1 connects to node 2, node 2 connects to node 3. The code uses 3 nested loops. The outer loop picks an intermediate node. The inner loop checks for all pairs I and j, whether I can reach j through that intermediate node. If yes, we mark it as reachable. After running the code, we print the final matrix. Example input and output. Let's see the output. The input matrix is 1, 1, 0, 0, 1, 1, 0, 0, 1. The output after running Warshall's algorithm is 1, 1, 0, 1, 0, 1, 1, and 0, 0, 1. This means node 1 can reach node 3 through node 2. So that new path is added. So we get the full reachability matrix. To conclude, Warshall's algorithm is an easy and systematic way to find the transitive closure of a graph. It uses dynamic programming to check all possible paths in a clear and efficient way. It's widely used in real-world applications where we need to know if something is reachable or connected. I hope this video helpful you understand Warshall's algorithm in a simple way. Thank you so much for watching. If you found this helpful, please like, share, and subscribe for more data structure tutorials. See you in the next video. Bye bye.